Hello friends! Today we'll continue working with arrays in different ways by setting up a game of Old Maid. I've already gone ahead and created a script named Old Maid and overridden the base node's definition of the ready function. In order to play Old Maid, we need a deck of cards, which is a collection of variables which we can hold inside an array. Since the game of Old Maid doesn't really care about the suits of the cards, we can ignore that information, and each element in the array only needs to contain the card's rank, from ace to king, as an integer. To generate our deck, we can use a for loop, but instead of using the for loop to iterate through an array, it can just be used to count through our card ranks. Starting with for, we can declare a variable to represent a card's rank, followed by the keyword in, then specify a number. If we were to consider king to be a number, it would be the 13th rank. For now, let's just print out rank so we can see what happens. The for loop starts with a rank value at 0 and counts up to 12, repeating this loop and print statement 13 times. For the sake of our sanity, it might be a good idea to consider card number 2 to be represented by rank 2, and thus ace would be 1 and king would be 13. While starting a for loop at 0 is really helpful for iterating through arrays since their first index number is 0, it isn't that helpful in this case. We can change the way a for loop counts by replacing the 13 with a function call, range. Function calls are followed by parentheses containing arguments. The arguments for this function are the lower and upper limits of the range. The lower limit will be included in the range, but the upper limit will not be included. So range 114 will contain all numbers from 1 to 13, and we can see that is printed out in the output. Another way of adding information to an array instead of using the square brackets and index number is to use a function named append. This append function accepts an argument of the value being added to the array. This will position the value being added to the end of the array, wherever that may be. And since there are 4 of each rank in a deck of cards, 1 for each suit, we should repeat this line of code 4 times for every rank. We can do this with another for loop, this time starting at 0 and counting up to but not including 4. Printing out the deck, we can see our array has 4 of each number from 1 to 13 for a total of 52 cards. But to play Old Maid, we want to remove 3 of the queens, or in this case, 12s. So in our for loop that is iterating through the card suits, let's check if the rank is 12. And in this specific case, we only want to allow one 12 to be added, using the keyword break to instantly break out of this loop. Break will only end the most indented loop it is currently in. So it will end the suit for loop but not the rank for loop. This will then increase the rank to 13 and proceed with adding 4 13s to the deck. And testing it out, we can see how there is only one 12. The first thing that happens in our game is shuffling the deck of cards, which in GDScript is a simple built-in function of arrays. We only need to call this function and we can see that the cards get shuffled in our deck. We will also need another variable, an array of hands of cards to represent our players. Each hand inside the hand array needs to hold multiple cards, so they are also arrays, which we will need to initialize before we can use them. So counting from 0 up to but not including 4, we can append a new hand to the array. Our hand starts off as an empty array, represented by square brackets. If we imagine our deck of cards, the front of the cards being the side with the rank and suit, the back of the card being blank, then we might also imagine the deck being face down, the front of the array is the bottom of the deck, and the back of the array is the top of the deck. The process of dealing out the cards can be done by iterating through our deck, but we do not actually need to reference specific cards at all, since it doesn't really matter what they are, only that the card is taken from the top of the deck and handed to a player. So to remove a card from the top of the deck, we can call another function. This one is called popBack. It not only returns the last element in the array, but also removes it from the array. We then want to add this card to the player's hand. and we'll start with player 1 assuming player 0 is the dealer. Just like we can use pop back to remove a card, we can also add a card with push back. The card we are pushing onto the back of the player's hand is the same card we are popping from the back of the deck. So we can simply put this function call inside the brackets of the function call and use its return value as the argument to the push function. Using pushback is the exact same as append. The append function is a legacy of strings, since they are usually stored as arrays of characters, while push and pop come from using stacks or queues like we are doing now. To deal our next card, we'll need to increment the hand that is being dealt to. So let's store that in a variable as an integer and give it an initial value of 1. Replacing the 1 in our array index with our variable, we'll need to increment it by 1 after each card is dealt. But this will obviously just count up to 51, and there are not so many hands. So we'll need this number to return to 0 each time it reaches 4. This can be accomplished using our trusty modulus operator, assigning hand to be modulus equals 4. But if we want to allow our code to work with any number of players, it would be better to replace 4 with the size of our hands array. To see where we are so far, let's print out our hands by iterating through the hands array and printing out each one, then print out the deck. We can see our 4 arrays and the deck is empty. We can even change the number of players and the cards will deal out to the correct number of hands. Our ready function is getting rather large. We can organize our code better by declaring our own functions. Separating our logic into small chunks, we have a section that creates our initial deck of cards, one that creates the player's hands, and one that deals the cards. Using the keyword func, we can give each of these blocks of code a name, followed by parentheses and a colon. Initialize deck, initialize hands, and deal. Then the ready function can call each of these functions in sequence. Our functions can also accept arguments, such as the number of hands we want to have. Let's pass 4 as the argument. To write our function to accept the argument, we need to add a matching parameter inside the parentheses of the function declaration. Much like declaring a variable, it has a name and optionally also a type. Since we are using this to resize an array, it's a good idea to restrict it to be an integer. We can then use the parameter inside the function much the same way we would use any other variable. The last thing we need to do to start playing would be to remove all of the pairs from each player's hand. So iterating through each hand in the array of hands, we can call another function to remove the pairs from that hand, passing the hand as an argument. Giving this function a definition, we can then accept a hand as an array parameter. We will need to iterate through the hand with a variable, let's call it card1. But we can stop before we get to the last card. So we'll only go from 0 up to the size of the hand minus 1. We can then iterate a second time in much the same way, but this time start at the card after card 1 and go all the way to the end of the hand size. Inside these two for loops, card 1 and card 2 now contain every unique pair of cards in our hand, so we can easily compare the two cards to see if they are a match. If they are, they can be removed from the hand, starting with card 2. If we removed card 1 first, then the index of card 2 would actually change as a result, since all the cards would move one position. If we find a match, we don't want to continue this loop, or either loop, but we want to restart the entire process again. A simple way of doing this would be with a while loop, and a Boolean variable for whether or not we found a pair, with a default value of true. While a pair was found, we can immediately set it to false. This allows us to enter the loop but not stay here unless a pair was found. In other languages, you could do this with a do while loop instead. If we find a pair, we can set the variable to true, then also break out of both loops, resetting the while loop. If both for loops complete without finding a matching pair, found pair will be false and the while loop will break. We can repeatedly run our simulation and see that none of our players' hands will ever contain matching pairs, and the players are ready to start playing their game of Old Maid. In the next lesson, we'll use another form of flow control. I'll see you in the next lesson.